Hey everyone, welcome back to another video. Today we have a 6R140 on the bench. We're going to tear it down and inspect it. It's out of a 2017 F750 water truck. So it's a PTO unit, as you can see. And the backstory on this is kind of unusual in that this is actually a Ford Reman replacement transmission that has around 300 miles on it or so. And what the customer had stated was the bypass valve that is there in the transmission has been seizing in the bore, causing a restriction or total blockage, and prevents fluid from moving through to the coolers so that heat can be exchanged. And as a result, the fluid inside the unit is simply cooking off. I mean, he's recording temperatures of in excess of 270 degrees. This has happened to him now multiple times. He's a contractor. He owns a construction company. He's got a small fleet of these trucks, and basically what has been occurring is Ford would, warranty the unit out, and then he'd run into the same problem again, and a couple times he had to go through the same process of taking the transmission out, putting a new one in, and back and forth. And he, I guess, is pretty much fed up with it. So we're going to tear it down, inspect it, see what we can find, see if we can find the blockage that's causing this issue with the fluid circulation, so that when we go back with it, it doesn't last 300 or so miles before it cooks off again. So let's get a little bit closer to the bench. I'm going to start at the back of the case, get that bolt-on yoke off, and then we'll move the extension housing and tackle that big giant output shaft nut, and then from there we'll start moving through the rest of the case. So we have the torque converter here, and as you can see, it's pretty much charred. I mean, it's not the worst I've seen. I had another one here that was all black. I mean, that thing just straight up melted down on the inside, but this one's pretty bad. So 18 millimeter on this bolt-on yoke nut. Note the blue Loctite. We'll reapply some Loctite when we go back with it. See, this just slides out for us. Nope, might need some persuasion. I just had to smack it a little bit harder. Maybe there's an O-ring or something in there. Big and beefy. Alright, so anytime you have a slip yoke of any kind, nature, or sort, you want to make sure that you scrutinize it for any potential problems. Now, this being a brand new transmission, we would not expect to see anything like grooves cut into the journal on the sealing surface, but you never know. I mean, this is not what I would call a high RPM, high-speed vehicle. So, at the same token, you always want to check to be sure. All right. Also, make sure the splines are in good shape. This does not look new to me. It looks like it's got some miles on it. I'm gonna put this over here. And then you should be able to take off the extension housing without removing the mount there. So what I'm going to do is I'm going to put a couple blocks of wood, because the only thing holding this transmission from kind of going topsy-turvy on me is that rear trans mount. Let's see if I can get a couple blocks of wood over here to stabilize it. Alright, so now we have the extension housing and trans mount off the bench. Give you a little bit better view of the festivities. So, let's see, 13 millimeter. Yeah, you can knock the seal out too if you want in advance. I'll just take it off once everything's cleaned up. New seal will have to come from Ford. I don't know that one of these are included in the aftermarket overhaul kits. And there's one more right through here. Did I get them all? There goes my stability. Okay, so you'll notice here there is no output shaft seal for your two-wheel drive units. The 4x4s all have them. This is true of the GM 6-speeds as well. So we expect to see pretty much every applied element in this transmission heavily scorched, burn up to a crisp. Alright, notice you'll have a seal here. Okay, that'll be replaced. And then you have your mount. And we want to inspect the mount that we have, given we have it, for any signs of cracking here on the rubber portions or anything else that would otherwise concern us. Alright. So what we have to do next is heat this nut up. I like to use just a small propane torch. I wouldn't use an oxyacetylene torch here unless this thing just refuses to come off. The reason for that is the bearing and the race that are located behind this nut. I don't know that they're available. They may be available from Ford, but I don't know that they're cheap either. So this nut I would also replace. These nuts, again, not cheap. They're about 120 bucks or so out the door from Ford. But if you have a unit that has gone through like a serious overheating event, or multiple overheatings, chronic meltdown and whatnot, it's a good idea to replace this. Let me get the torque converter out of the way because we're going to need the bench space, and then we'll continue. So my recommendation is 3 to 5 minutes. Kind of just keep your heat moving around, but you don't need to be like, super quick with it. Just go around slow and steady all the way around the nut so that you can expand it and melt that thread locker. Okay, you want to make sure that you clean this area of fluid and anything else that might be back here. Any crud, any debris, anything that might catch on fire. So 3 to 5 minutes of this, and then you can use either a breaker bar or a hammer wrench in combination with the spanner socket that you're going to need to remove this nut. So we'll bring you back once we're ready, and we'll go ahead and attempt to take it off. Now I'm going to commit a cardinal sin, at least according to all the instructions that come with these spanner sockets and the manual, and that is use an impact. So snap on 1/2 inch drive. Make absolutely sure I'm going in reverse. Well, you have to do what you have to do. I did not try to catch the nut because it is very hot. That fluid stinks. So do an inspection of the threads, make sure that none of them are boogered up. And then we'll grab the bearing and the race. So this locating lip faces inboard. And then this is your race. So you can see the witness mark here that faced out or faced you, when you're looking at it from here. So I have a small collection of these nuts. I'm not really sure what I would use them for, but I always put a new nut on whenever I go back with one of these 6R140s. Alright. Inspect the bearing. I mean, it got a little warm, but I mean, it's normally subjected to 175, 180 degree heat anyway. Soak it in some Mercon. If it's bad, if it's making noise like this one, a little bit of noise. If you're not sure, just replace it, no big deal. Alright, let me reposition the camera. We'll unbolt the case from the bench and then we'll continue to tear down. Okay, with that output shaft nut off and out of the way, we can go ahead and continue with the rest of the tear down. So these PTO units, I don't see them too often, but this is kind of what they look like. So you can just basically pull the outboard gear off with its housing, off the studs. Okay, assuming you're not super clumsy like I am. Alright, here's your part number. You just want to inspect the gear, make sure it's in good shape. Make sure that the little thrust washer here is not damaged. Make sure the faces of each side of the gear teeth are not cracked, fracturing, nothing unusual going on. Same with the crest. All the teeth all the way around the gear. Make sure it spins nice and easy. Okay, I mean, this is supposed to be a brand new transmission from Ford. So you would not expect to find a lot of heavy wear. I mean, the customer did not even use this PTO unit on this thing. Never used it. Basically couldn't get it to, to keep from overheating. So here's your gasket. You can buy new ones. Always want to replace your gasket. And then the studs have 5/16 Allen heads, so you could take them loose. A lot of RTV on here. So you should be able to see into the pump housing area with the PTO gear on the pump. Just spin it, make sure it's spinning nice and free. And then we'll go ahead and remove the nut here for the selector, 15 millimeter. Then you have a little seal here. Get these bolts out of here. Alright, we'll take our bleeder hose or vent hose off. And we'll want to make sure that this is not obstructed. So we can just clean this off. I'm going to put this out in the back. Inspect it later. You want to make sure there's no cracks in the hose, obviously. So there's a secondary inboard gasket. Alright. So with your wiring harness, there's tabs here. You want to kind of collapse those in so that you can get the harness out from the inside of the case. There's one at the 12 o'clock and one at the 6 o'clock position. And we always replace the harnesses, so it's not like if you break it, it's going to be a big deal. So we broke that one. Never reuse any electrical components, especially if you have severe overheating episodes in the unit. I mean, that's just a recipe for disaster. Not really sure what the story is with these things. Alright. let's see. We have, just real quick so that you kind of know what you need to look for when transmissions come in when it comes to information on ID tags and stickers. So you're going to have your solenoid strategy and operating software version ID here on the sticker, along with codification to indicate your production and other information. So you want to make sure that the stickers, or the codes I should say, that are on the stickers match what you see in the ECM if you're a full service shop. You want to make sure that matches with the information tag on the valve body that informs you of the valve body ID and solenoid strategy ID. Okay, the solenoids for these units are slightly different based on model or submodel or engine application, so you want to make sure that you don't put the wrong solenoids back on these or any of the Ford 6-speeds. So they're all in that, they're all the same in that respect. All right, so here's the pump. As you can see, significant overheating here. I mean, your signs of overheating everywhere. You have a torque converter seal here if you're having problems with the converter coming on when it shouldn't be, like when you first fire up the vehicle, put it in drive, and the converter is pulling the motor down. Check this seal, make sure that it's not boogered. That could be the reason why, especially on fresh overhauls. The torque converters are extremely heavy, and it can be difficult sometimes to get them to go on, especially if you aren't perfectly square when you come in. So you cut this, then all kind of problems will happen. All right, 6 to 18 thousandths for your front end play. All right, I could barely move that, so I did take an end play reading before we're off camera, I should say. I did film it, so I'll flash the results. Front is 6 to 18, the rear is 31 to 43 thousandths. So 10 millimeter on your pump bolts. Oops. Okay, these pumps, as far as I know, are all the same for PTO and non-PTO applications. I'm going to go grab that bolt off the floor. Alright, now what we're going to do is flip this thing over so that we can take the pan off and start going through everything on the belly of the case. Alright, 8 millimeter on all those pan bolts. .97 inch-pounds is the torque. Nasty. Nasty, nasty. So, product overheating, that's what happens. Transmission basically melts down and cooks off. We're going to put this pan in the back. Otherwise it'll be in the way. Alright, so we'll go ahead and take the filter off, and then we'll disconnect our electronic or electrical components, and then from there we'll take the valve body off and have the case belly free. All right, so 8mm on all your valve body to case bolts, 97 inch-pounds of torque. So you're gonna have 3 bolts that go through the filter, holding it onto the valve body. This bolt back here is going to be longer than the other 2 bolts. This is going to be your longest bolt that goes on the case belly. Man, that stinks. Stinks! Alright, I'll zoom in on that ID tag real quick just so you can see it. Alright, so you have your barcodes, they can be scanned, and then you have your solenoid strategy ID that will inform, you know, what you need to do in the event of either an overhaul or reprogramming or whatever the case may be. Alright, so transmission fluid temperature sensor, it's going to be here. And then you're going to have 2 speed sensors, front and rear. And again, these get replaced. Here's your disconnect tab, that's what I was looking for. Just press down on this tab right here. And it'll come off. And then this has a similar tab. Just press down, pull up, the tab is going to be right here. Alright, then you have your main case connector that can be gotten at later. So then you want to disconnect all of your solenoids. My hands are absolutely super slippery. So you have tabs here as well. And what the book recommends you do is just simply take needle nose pliers and pull these off, but you can get them by hand if you just squeeze. So squeeze and pull. All right, and you can get that out of the way. Okay, so gonna need a Torx. Say it's a Torx 30 or Torx 40. But basically, you're gonna have your valve body assembly to case bolts indicated with an arrow. One here, one here, one here. Okay, none of these other bolts come off. Bolt here, bolt here, bolt here, and then of course you had your filter bolts, which kind of serve dual purpose. And then get my Torx. Ah, that was brilliant. So I have a whole string of magnets there, all along the backsplash to catch things like this when I just clumsily let them slip out of my hand. Alright, so up to you in terms of what order you want to take stuff off, but I'll take my Torx bolts off first. So here's your 2/6 clutch feed. Then you're going to have your feed pipe. So remember I was telling you, you're going to have 2 feeds for low reverse, and then you're going to have a feed for the lube circuit for your extension housing bushing in the 2-wheel drive applications. And it's going to be right here. Alright. This bolt holds in your low reverse piston and piston housing, so 8mm, we can take that off as well. Okay, the ATSG manual has all the bolt lengths and their purpose and their location, so don't worry about trying to memorize or recall exactly what length bolts go where. I mean, I'll do the best I can to show you. This is a reusable gasket. Not that we would reuse this one. The new one will come with all the rest of the parts. So I like to keep these reusable gaskets because I use them as masking tools when I want to paint a transmission. So a given unit will get paint. So these bolts are all the same length. Alright, you can come in here and just remove your linkage arm to your manual valve. Easy enough, you kind of saw how it went. And then the valve body is just going to come off. So grab it here, and then tube seals will come with the mounting flange on your feed pipe assembly. Alright, let me move the camera so I can get you a little bit closer so you can see where tube seals go, as well as all the valve body and case seals. So here's your green tube seal where it went, and you have a blue tube seal here. Alright, so here's a lube seal. Here's your seal for your 2.6. It's your 2.6 clutch. And then you have the seal for low reverse. And then the blue seal's the lube seal for the extension housing bushing. Alright, so we can remove our speed sensors. Alright, these speed sensors will not be reused. We will replace them with new. Okay, they are both the same. And those bolts are the same as well. Get them where you can see. They're exactly the same. Alright, note the anti-clunk springs position here. I'm not going to take it out until we get to the point where we're ready to remove the rear planet. Reason being is I just want to show you how it looks from inside the case and how it needs to go back so that there's no misunderstanding or confusion. Alright. So parking pole guide plate, 8mm, you have 4 bolts. And then notice here, you have your retainer spring. Goes just like this. So the engagement hook on the pull side of the spring faces rearward, and then this faces forward on the bracket side. Okay. Alright, now you can get that harness out of the way. I'll just put this in the trash. I mean, again, if you're not used to doing these, you may want to keep all these parts just for reference so that you're not in a position where you get a part and you're unsure if it's the correct part. Alright, so here is your rooster comb and then your retention or roll pin for your range position / rooster comb assembly. So 8mm on that detent roller bolt. And that allows you to move the rooster comb around freely so that you can get to the roll pin. And let me see if this punch is the right size. I think so. Alright, so come at it like so. Smack it free. And then just collect it where it is here in the case. And then just pull your selector shaft out and then grab your assembly. So we are not going to reuse this range switch. It will be replaced as well. All electrical components for my overhauls always get replaced. I don't ever reuse them. And grab up all of our seals. So the 3 black seals are all the same length. Same dimension, you know, inner outer diameter. And then you have your long green seal. And then you have your small blue seal. Again, you can save these if you want for reference. It's up to you. Alright, so let's take a look at the valve body. So there's O-rings here on your feed pipe assembly inboard. Let me just go right here in these holes, and then you have your 2/6 feed going right here. So new O-rings will come in the kit along with all the other soft parts, paper, rubber, and all that good stuff. Same with your valve body to case seals. Looks like that one's going to be stubborn. So I would expect this valve body to be in like new condition when it comes to a sealing integrity perspective when I go to vacuum test it. I'd be surprised unpleasantly if it was not. Alright, let's talk about the solenoids and solenoid banding real quick. So all these solenoids have what's called a band number. Okay, some are normally high, some are normally low. And what you want to do is make sure you record each of these respective solenoid positions here on the valve body relative to some anchor point. So in other words, you know, maybe you make a score mark here on this side, you know, some sort of like X. And then what you'll do is on a piece of paper, you'll start writing down the order of all the solenoids based on their band number. Okay, you can also differentiate them based on the color of their snouts. You notice some snouts are dark, some snouts are light beige or brown. So this is the lower valve body. You have your spacer plate, which we'll be replacing with a Ford OEM spacer plate. And then this is your upper valve body. So I'm going to disconnect, or I should say disconnect. I'm going to separate the two halves so I can clean this valve body off. Because we're not going to replace any, we're not going to reuse any of the solenoids. So at this point, I'm going to just throw this thing in the hot tank, get it all cleaned off, then I'll tear it apart, fully clean it, stuff the empty cases in the hot tank once again for about 5 minutes, clean them all off, and then put everything back together and vacuum test it. I'm going to leave all the bolts in, and we'll take them out like one by one so you can see where short bolts go and where long bolts go. There's 2 other bolts holding the spacer plate to the upper valve body. I noticed I generally worked, started from the perimeter and worked my way in toward the center. I mean, how mandatory is that? I don't know, but it's just something I do out of habit when it comes to valve bodies that look like this. So most of these bolts are going to be this length here. Only the 4 in the back are longer. Alright, so you're going to have pry points as well, so you can separate the halves. They are secured together with alignment pins. So it's pry point here. And pry points there. Sometimes they just come off. You just go like this. You might get one side that wants to fight you a little bit, no big deal. There we go. Alright, so you're going to have 3 accumulators. Okay, 3 accumulators on your lower valve body, and then here are the 2 Torx bolts holding the spacer plate to the upper valve body. So, double-decker valve body assembly. Torx 30. Get that out of the way. Alright, don't worry about the part numbers on the spacer plates. What you need to do is go to the Ford dealer and let them know the last 8 digits of the VIN, and they will sell you the correct spacer plate for your application, transmission, vehicle, year, and all that stuff. Okay, so you have 2 little poppet valves here. Then you have check ball here, a check ball here, a check ball there. So it's like 2 check ball and 3 check ball valve bodies. Okay, here's a spacer plate. You're going to need to keep this aside. So this went here, just like that. So that's that conical pickup, and it just comes off. Oh, maybe. I'll clean the spacer plate off and deal with it later. So the spacer plates I also keep for reference. I do not reuse them under any circumstances. And this one in particular took a beating. So I'll have to get a new one. New one for that one anyway. Nasty. Nasty. So, customers saying there was a restriction that prevented fluid from flowing through to the coolers and then returning to the transmission with freshly cooled fluid. And that is the reason it was cooking off. I don't see anything in here. I'll blow air and water through all that. The 6R140 case is so big it won't fit in my hot tank, so I just pressure wash it. Alright. So the castings are ready for their preliminary wash. you know, again, leave your solenoids in there. If you're not going to reuse the solenoid, or if you plan on reusing the solenoids, I should say, if you plan on reusing the solenoids, then I wouldn't put them through the cleaning cycle. But you'll want to record their band number and position before you do anything further with them. Alright, let's reorient this camera. And I think I'm going to move you back a little bit. Get this pump out. Let me get this pump out. You know what? I'm going to shift the transmission to the right so I can get the pump assembly out. And then we'll start taking stuff out of the case. Alright, we're going to get to the center support where big giant snap ring pliers will have to come out. The snap rings in these transmissions aren't quite as beefy, believe it or not, as the ones in the 6Ls, 6L80 and 90. Alright, so I'm going to move you down a little bit. Alright, so what we're going to do is come over here with a pry bar, and we're just going to force the pump forward. Okay, hold your 3/5R clutch drum so it doesn't try to come with it. I saw the bolt there. So this is a PTO pump. You have your PTO gear, this is your pump housing, this is your pump body, and then this is the stator shaft. So you want to check all your splines on everything that has them. And then what we need to do is separate these two halves so that we can ultimately scrutinize the pump body and the housing. So 10 millimeter, you have two different lengths of bolts here, short bolts and long bolts. All right, this is the stator support. The stator, you have a gasket or intermediary wear plate layer, and then you have the pump housing, and then you have the pump body. Notice there's an O-ring on the housing, and there's going to be an O-ring on the body. So keep two long bolts, keep them handy. They're inboard because you're going to need them to separate the pump body from the housing. Okay, these all get 18 foot-pounds of torque. And you tighten and torque the inner bolts and then the outer bolts. So you can immediately tell where your short bolts go and where your long bolts go. Looks like I got one more. Short bolts go here on the stepped flange portion, and the long bolts, go in these other non-step locations. Okay, so we have a PTO gear, makes it a little bit easier to separate these, separate these halves. So what I want to do is get a pry bar, kind of come in between, and just gently start working the stator support off of the pump housing until you separate it completely. And then you can lay down your assembly. Notice you have a bearing. Check the condition of the bearing. I'm going to recommend we just do a whole bearing kit in this thing. When they overheat like that, it more than likely has worn the needle bearings out, shorten their lifespans appreciably. So, I don't like to reuse that kind of stuff whenever there's a big meltdown occurring. Alright, so here's your PTO gear. And it's got a little needle bearing in here, check it. Check the gear itself. You have an O-ring and 2 sealing rings. These are Teflon 1-piece sealing rings, and you need a special tool to install the new ones. So I'm going to get rid of these because they're filthy. So you have your O-ring here, and then these 2 sealing rings. And I just use this kind of cut off 90-degree pick to bust loose the sealing rings. To my knowledge, there are no scarf cut sealing rings for these transmissions, to my knowledge. For those watching, especially those of you that do these all the time, if you know of a supplier of such sealing rings, please let us know in the comments. That would be greatly appreciative, because, you know, to spend the kind of money that folks are going to need to spend just to install sealing rings in these transmissions, you know, that's going to be kind of beyond the pale for most folks. Adapter case, OTC, you know, Ford's OEM tool manufacturer for all of their transmissions, engines, and other, you know, other vehicle parts. They're available on eBay or through Adapter Case, you know, or Transtar, wherever transmission parts are sold. But you're paying 2 arms and 3 legs, I'm telling you. All right. If you get that joke, go ahead and put it in the comments. This is going to be your plate here. It goes on like so. All right, now what we need to do is grab a couple bolts so that we can put them through the pump housing and into the pump body, and then separate the body from the housing. These in a little bit further. Typically it doesn't take this much effort to do this, but you know, sometimes it does. Okay, here's our housing. And while you see a lot of witness marks, what you're really looking for is any actual scoring that you can feel. Okay. Now, I say this in a lot of my teardown videos. I'll say it here. I don't ever do a real inspection of these things, any parts in a transmission, until you know, everything's cleaned off, you know, free of nasty ass fluid and whatnot, and I can see and you know, get access to everything nice and easy without the fluid distracting me or concealing potential defects. So I'll kind of show you what to look for, but I'm not really looking at it critically. Alright, check this this race in here as well for wear. Okay, note this little drain back. This is like a drain back stop. They started putting those into these 6R140s, I want to say in 2013, maybe 2014. Prior pumps did not have them. So new ones will come in the kits, at least the ones from Transtar. But you know, you want to make sure that you keep eyes on this. Don't throw it out, because if you buy a kit and it doesn't have one, or for whatever reason they, you know, supply chain issues prevent them from being readily available, if this is in good shape, you can put it back in there. Superficially, this pump housing looks okay. And again, it's a 300-mile unit, it should not have any wear whatsoever. So here's the part number. You can match it up if you need to. All right, let me change my battery and then we'll go through the pump body and then we'll look at the stator support. Okay, let's take a look at the pump body and the gears. So notice the orientation. You have dots that indicate which side of the respective drive and driven gears should be facing. So we'll just wipe the working surfaces down, and then you're going to check all your surfaces. So you have your base or bottom, you have your priming crescent, and then you have your inner diameter. All of these surfaces must be flawless. If they're not, replace the body. So there are specs to adhere to when it comes to measuring pump gear clearance, and they are as follows. So your driven gear outer diameter to the inner diameter of the housing is between 3 and 6 thousandths of an inch. I'm not going to measure this now because, again, there's no nasty ass fluid. The clearance between the drive and the driven gear is also 3 to 6 thousandths when it's installed into the body. And then your gear face to pump body deck surface clearance needs to be 1 thousandths. So if you're outside of those specs, replace the body and put new body and gears. If you purchase an entirely new pump assembly in the aftermarket from Transtar or, you know, an equivalent supplier, you must take this pump apart. Okay, do not think you can just, you know, bolt it onto the transmission and go. Most of them will not have sealing rings. Okay, that'll be readily obvious to you, at least for the non-PTOs. The PTOs will not have sealing rings either on the gears. But what is not going to be obvious to you is that the O-ring on the pump body will likely also not be there. So you have to fully dress your pumps, in addition to inspecting them and checking them for clearances and all that good stuff, before they're ready to go back in. Because if you do not have an O-ring here, you will not have third, fifth, or reverse gear. So very bad. So again, superficially, other than some very light scoring here on the faces of the gear that faced rearward, this pump looks okay. But again, I'm not doing a real inspection of it. I'm not making any decisions based on what I see right now. Gotta clean it. Okay, so here's our stator and stator support. We got bushing here. I'm probably going to replace this bushing. Most of these bushings in this transmission should be good, but you know, they may require replacement given what has happened in here. So let's check our working surface. So superficially, it looks perfect. Here is our selective spacer. So this will go onto the sun gear. When you install your pump, do not put the spacer here like this. Okay, install it onto the sun gear, because if you put it on the stator, the likelihood of you getting it perfectly centered like this here at the base of the journal is basically 0, and you will not be able to install the pump fully, and you're going to wonder what's hanging it up. So let's measure the thickness of this thing. So it looks like we're at 214 thousandths thick. Focus. 214. So when I measured the end play in the front, I got 15 thousandths, which is fine. I mean, it's on the high side of spec, but not the end of the world. Check inner diameter of PTO gear, check your journals, you know, again, check the teeth, check this needle bearing. I mean, if it's in good shape, it's not making any noise, or it's not missing any needles, it should be fine to reuse even in, you know, situations like this. But when in doubt, swap it out. So if you're not sure, replace it. All right, so what I'm going to do is grab a straight edge and see if that's truly flat. So a straight edge with a 1 thou feeler gauge is a pretty good method for identifying situations where working surfaces are not flat when they should be. Alright, you can shine a flashlight in the back here too and see if you can see light poking out. Again, on a 300-mile unit, this working surface should be absolutely cherry. There should be zero warpage whatsoever. So it appears to be good. Looks fine to me. Checking splines. Okay, check journals. Check splines here. Check inner diameter for any kind of sealing ring cut or whatever. So that's the pump assembly. Let me reposition the camera so that we can empty the rest of this case out. Alright, what I'm going to do is I'm actually going to turn the whole entire transmission so it's facing us instead of, you know, pulling everything out that way. And then I'm going to dump this fluid real quick too. And get this nasty ass fluid out of here. So, if you plan on taking on a rebuild of one of these units yourself, it is absolutely imperative that you have the requisite tooling and equipment to handle something this big, this heavy. If you don't, you are putting yourself and the job at huge risk. Okay, I don't mean to sound like a nag about it, but I cannot even begin to tell you how important that is. So, specialized fixtures. I use an engine stand. I mean, you watch my videos, you've seen it millions of times now. It's 1,250 pounds of capacity, not foot pounds, pounds in terms of weight and load. There's a special tool that Adaptacase makes that allows you to hook this into the input shaft and lower the entire input assembly into the case in a safe manner using either some sort of chain hoist, a gantry crane, or even a shop crane that's tall enough. And this way you don't risk hurting yourself. It's like 125 pounds, I believe, this entire assembly that we're about to pull out. So I'll move this as far to the left on the bench as I can to free up space. Alright, and then I'll move the camera a little bit as well. Alright. That's not what I wanted to do, but sometimes unfortunately that happens. Alright, so I'm going to reposition the camera now so we can go through the input assembly, and we'll talk through clutch clearances and selective snap rings and all that good stuff while we inspect the various clutch packs. Alright, so you'll have your bearing here in the back that goes to the center support. It's got two tabs or ears. And this came apart. So again, I'm going to be putting a bearing kit in here, so these bearings are basically junk. Alright, so now we have our 3/5R clutch drum, our 3/5R clutch hub, our 1, 2, 3, 4 clutch hub, and our 4, 5, 6 intermediate shaft and clutch hub that's inside. So let me locate the opening for the snap ring for the 3/5R drum. Looks like it's literally at the 6 o'clock position. There we go. And this thing got really hot. Alright. So again, these are selective. So 3.5R. They're available from Ford. And I think the aftermarket sells them as well. Get that stator out of the way. Alright, so you can basically pull everything apart now. So here's our intermediate shaft 456 clutch hub assembly. You'll notice the presence of bearings. Then we have our 1, 2, 3, 4. A bearing goes there. And then our 3.5R. I think these are partially welded to this thing. One of these clutch plates is. Yeah, this one. There we go. Smoked. So with your hubs, you want to check for chattering here on the sidewalls where your frictions are riding. If they're really scored up, a lot of deep grooves, you want to replace the hub. Check splines, your bushing. You got 2 bushings in here. So that hub superficially looks okay to me. So he's going to need a backing plate. And this thing is burnt to a crisp. And then here's your top friction, or what's left of it. Steel, friction, steel, friction, steel, friction, steel cushion plate. Nasty. Tore up. Alright, so here's 4.5 clutch hub. This is the bearing. And it goes like so. And then here you have your other bearing. You have the locating flange right there, facing the hub. Okay, check this little bleeder orifice, make sure it's not plugged. Check your splines. Again, check your lugs on your 4.5/6 clutch hub. And check the journal here. This looks okay. Superficially looks okay. Alright, let's look at the input shaft 4.5/6 clutch drum assembly. So again, selective snap rings. I will flash clearances on the screen for each of these clutch packs, but I will tell you straight away that the ATSG manual's clutch clearances that they publish are a little tight. So I'll flash both the ATSG manual's clearance specs as well as those from Gears Magazine. And the Gears Magazine is generally what I adhere to, not the ATSG, at least for these front clutch packs. So Borg Warner frictions. This is 4.5/6. There is no cushion plate. These look perfectly fine. So he lost all movement basically, lost reverse, and then lost movement and forward after about 300 miles. I'll go ahead and remove the snap ring on the press, and then we can take a look at those pistons. They're going to be replaced, but I don't expect to see any anomalies given what the clutch pack looked like. You know what, before we go to the press, I'm going to reinstall this clutch because I want to pressure test in here, because there can be a tendency for leakage to occur. Now, I don't believe that will be the case with this particular drum, but you want to always do that. So I'll fire up the air, we'll put the clutch pack back in, and then we'll do that pressure test. All right. So to do this test, we're going to just pour a little bit of transmission fluid in here, and then we're going to put air in the 456 feed and see if we have any bubbles coming from that weld line all the way around. So anywhere in here is, you know, the area of interest. All right, let me fire up the air and then we'll do the test. Okay, let's go ahead and conduct the test. So you can put air here and block this off here. So it's a dually fed circuit. So then what you're going to be doing is just looking for bubbles. You see bubbles anywhere along the weld lines, you know the drum's no good. Again, highly unlikely with a 300-mile drum, but you never know. 30 to 50 psi air is sufficient. All right, hold it, finger off trigger, and then release. Okay, I don't see any bubbles. The drum appears to be fine. So drum and clutch pack are healthy. So now we can go over to the press and remove the pistons. All right, you may notice the 4 locking tabs here on the balance piston. When you go back with this thing, you want to make sure that snap ring's engaged on all 4 of them. So this tool that I'm using to compress everything is an OTC tool. It's actually intended for this same drum, but in a 6R80. So it is OTC 307209. It is ever so slightly too small for the 140s, but it does work. And, you know, it'll allow you to take the snap ring out. All right, back to the bench. All right, so here's your balance piston. This will be replaced with a new one. Of course, your snap ring. Just check the snap ring. If it's bent up, replace that as well. And then your return spring assembly. Again, you know, just check and make sure everything is okay with it. All right, now for the applied piston, you can just push that out with shop air. And you'll replace this as well on overhaul. given what I've seen so far, I'm starting to think that there was no restriction, but I could certainly be wrong. I mean, the customer spent a lot of time diagnosing this issue, and apparently it's happened to him, you know, with multiple units. So I don't want to just dismiss what he's been telling me, but at the same token, I don't see any obvious signs of anything being blocked. Now that doesn't mean that, you know, once I get further into disassembly and cleaning, I won't discover something. If I do, I'll bring you back, assuming we can't resolve it here in this teardown. But, you know, just starting to think that there's something up with this 3.5R drum. And at least with this transmission. Alright, so I don't have a checking tool to pressure test this thing. I want to see if I can get one made. If you guys know of a source for one on the open market, it would be a tool that's identical to the 6 speeds for GM, the 6L80s and 90s. Okay, here's your 3.5R apply ring. As you can see, you got toasty, but it should otherwise be okay to reuse as long as there's no cracks, no deformation, you know, no obvious signs of metal fatigue. So what I'm thinking is I would like to have a checking tool that goes in here, and you can put air into each of the clutch circuits for the 2 clutch packs and independently test this drum as well as test it for leaks here at the base welds. These are not known to have those kinds of issues like the GM versions, but you never know what you might find, you know, when you tear a transmission apart. So here you have a bearing for the front planet. Notice the orientation. Okay, the what do I want to say? The outer cover faces inboard on the planet. And let's go ahead and get our 1, 2, 3, 4 clutch snap ring out of here. Okay, this is also selective. Let's see what this clutch looks like. Okay, the bottom steel is still in the drum, but this clutch looks okay to me. So you have your cushion plate and then your bottom steel. Let's take a quick gander at the backing plate. It looks okay to me. No signs of bluing or overheating there. And another look at all of the frictions and seals. I mean, in theory, this whole clutch pack can go right back in just like the 4, 5, 6 clutch. So something could be up with this 3.5R drum, and you know, the drum combined with the 3.5R apply circuit. To smoke a 3.4 clutch like, or excuse me, 3.4, yeah, 4L60E on the brain. A 3.5R clutch like this, with only 300 miles on the unit, there's got to be something up with the drum, or perhaps a highly flawed valve body, 3.5R clutch regulator, clutch latch valve, something that, you know, a massive cross leak somewhere in this supply circuit that would have doomed that clutch to failure. All right, I'm going to get you closer so you can stare right down into the drum, because we got to take this planet out. All right, so like the 6R80s, the 140s require you to index the planet's engagement teeth with those on the balance piston, because believe it or not, this planet will only go back in and fully seat so that you can install the snap ring that you see there if it goes back in exactly in the same positions relative to where those dots are that it came out of. So if you don't index, then you're literally going to be rotating this thing one tooth at a time until, you know, you get lucky and it'll seat for you. So I'm just going to scribe on either side. You know, make sure you have marks that are readily obvious. You're not going to hurt anything by doing this. Just makes it more efficient for you when it comes time to pull it, or I'm sorry, to reinstall it. Alright, so basically my scribe marks are to the tooth immediately to the right of the dot on the planet. So here's a snap ring. Come on. So let's see, try and put it in, oops. Let's see if we could put it in any other way. As you can see, there is no way we can get that snap ring in there. Alright, so I failed to catch the sun gear, so we'll inspect that now, make sure I didn't break it. But you notice the recess here, that's where that selective spacer goes. So that's going to face down into the drum when you go to put the planet back in. Okay, you put it in this way, you're never going to get the pump in the case, assuming you put the spacer there. So check splines, check the teeth, make sure you didn't break the gear in half when you let it fall to the bottom of the drum. This looks okay to me. Alright, so we have our 1, 2, 3, 4 balance piston, that's what my finger is on now, the 1, 2, 3, 4 apply piston, and then below we have the 3, 5R apply and balance pistons. So I use a 3-legged compressor tool to compress this, and then we have the snap ring here. Once that's out, we can go ahead and you know, pull these 2 pistons out, and then we'll have to tackle the other snap ring, which is kind of unique in that it's what do I want to say, almost like a outward clamping style snap ring. In other words, it's not a traditional snap ring like this. So we'll go back to the press and remove this, and then, you know, remove the other one. Before we do that, let's just check this planet real quick. So check your captured bearing, and then check all your pinions. So you're checking for side play and vertical play. Okay. So that's the first one we checked. So far so good. Alright, this planet is healthy. Now let's go to the press. Alright, go ahead and compress the Belleville spring via the balance piston until you have the entirety of the snap ring free. Yeah, a little bit closer so you can see what's going on. Of course, now I can't see what's going on. There we go. Alright, if you have a foot press, and you'll need a pretty beefy one. The one I have is not sufficiently beefy for this transmission, but you can use a foot press to remove these, you know, compress the return springs and remove the snap rings. You're going to need some pretty good sized compressor legs, if you will, you know, that are rounded like this. I believe Adaptacase sells a set for like a couple $1,000,000, you know, just like all the rest of their stuff. So if that's, you know, something you wanted to do, you know, you can buy their set. The ATSG manual's demonstration transmission, you know, the one they were actually building for the manual. They show those Adaptacase compressor arms or legs or whatever. Alright, so here's your balance piston. My advice for those that are doing this for the first time, you know, these transmissions or 6R80s, GM 6-speeds and so forth, is to keep your seals on all of your pistons. Your apply and balance piston seals for this set as well as the 3.5R, because unfortunately most of the kits don't have all of these seals segregated by part. So you might be wondering what seal goes where, and they're all somewhat similarly sized in terms of diameter and appearance that you could conceivably make a mistake. So it's just easier to keep them on. Alright, let me see if I can get this apply piston out of here. Nah, it's too slippery. Alright, I'm going to go back to the bench. Alright, I use these you know, rubber tipped spark plug pliers to yank pistons like this out of their drums. You absolutely do not want to use regular pliers for obvious reasons, because if you're, you know, not sure, you have a sealing surface here on the inner diameter of the piston for the balance piston. Nasty ass fluid. Alright. So, like I said, I'm not going to really inspect this, but you want to make sure that this sealing surface is free of any defects, any scoring, any gouges. In fact, there's a gouge marker right there. I don't know if that's casting flash. This fluid out of here, or is that a bleeder orifice? That looks like some sort of imperfection, so I can feel it. Looks like the seal rides here, so it looks like it may be below the seal, whatever it is, but I don't like that, so we'll replace this piston. Alright, now the 3.5R piston is a little different in terms of the snap ring. So you'll notice, or maybe you'll notice, here's the snap ring. The snap ring never actually comes out of the drum. What you do is you compress the whole assembly here, and then you take flat blade screwdrivers and you compress this snap ring inboard into its groove. And then you go all the way around. Usually there's two primary lobes, one here and one here, for example. That's what I'm seeing. So on either side, and then once you release press tension, this should just pop out. Sometimes you have to, you know, hit it slightly with a hammer handle or something, but it'll pop up, and then you can remove these two pistons. So let's go to the press and we'll demonstrate that. Alright, so I'm going to compress everything down. Alright, you don't have to move the ram far at all. And then what I'm going to do is I'm going to take my screwdrivers, and you see how you can compress that snap ring into the groove, just like that. So I'm going to do that on both sides. Oh, maybe. There we go. Got one side in. Got the other side in. Now I just want to release spring tension. Slowly. And it's free. All right, back to the bench. So here's your balance piston. It's got a seal here. It's your return spring. Okay, the 3.5R return spring is markedly larger than the 1, 2, 3, 4 return springs, so there's no way you can mix them up. And then you have your apply piston itself, which is going to be in there. You have different O-rings down here, including an O-ring here where my hand is, another O-ring, or that's a snap ring. You have another O-ring here. Here's the snap ring for the 3.5R balance piston, another O-ring here, and then snap ring groove for the 1, 2, 3, 4. All right. Let me see if I can get this thing out of here. Alright, I marred up the piston a little bit. It was just stuck in there. I have plenty of these pistons, so we'll just replace this one. Trying to determine if the seal feels harder than it should. No, it actually doesn't. It feels fine. I mean, it was in there pretty good. It's the bottom O-ring. Feels okay. And then here's the O-ring for the top portion, or the top land of the drum here. It's really a D-ring. But either way, it feels fine. And then you have one more way down here. I know my hand's in the way, but I'll move it in a second. It's right down in there, in that groove. It also feels fine. So, got a bit of a mystery on our hands here so far, anyway. Alright, I gotta reorganize this bench. Get some of this crap out of the way so we can empty the rest of the crap that's still in the case and finish this teardown. There'll be a lot of cleaning up to do, that is for sure. Alright. So we have the center support and the rear gear set still to go. And then first we have to move a giant snap ring so that we can get the center support out of the case. And where we need to engage and hook up is unfortunately where all that fluid is pooling.
Get some of it out of there. Nasty ass fluid. Alright, snap rings out. And then now we need to grab the center support. So you have two slots here where there's going to be two keyways on that support. They can get hung up. I'm going to move you just to the side so that I can stand right in front of it, and then we'll yank it up or out. Or not. See what's keeping it. A lip here or something. Oh, there we go. Come here. All right, center support. All right, I'm gonna get everything else out in the case, and we'll examine the support and everything, you know, in the back here. All right, so you'll notice the design here of this Planet. In, I believe, 2016, 2017 time frame, Ford decided to eliminate the bearing support structure on the rear Planet, and they went with an open design. They realized that the bearing support portion of the Planet was not needed. All right, so here's your forward-facing sun gear bearing. And then on the back side, there's a recess along with your spacer. And then you have an open axial bearing. Goes like so. So, front bearing, front sun gear, axial bearing with the locating radius facing rearward toward the aft sun gear. Come on. So you have the recess facing front and the beveled side of the splines facing rearward. Alright, notice you have an anti-fretting ring. So this was part of the center support design change, and an anti-fretting ring was installed between the support and the Planet. Alright, now what I want to do is get you in so you can see directly into the case, because I want you to notice the orientation of the wide lugs on the case and the mechanical diode one-way clutch assembly, because they all have to be clocked in the exact same position that you see them here when you go back with it. Okay, hopefully that's in focus. So here is our anti-clunk spring, you see it here. right here, and it's positioned at a wide lug. Then you have your other lug here. Notice the wide lug interlocks with the wide lug in the case. The wide lug on the diode interlocks the wide lug of the case such that this lug here is offset to the left relative to the lug in the case. Okay, and then likewise for the other one over here, it is offset to, in this case, this would be the left. If you're looking at it here, this one would be offset to the right. So I'm going to go ahead and pull the anti-clunk spring out. And all I did was just take a pry bar and just pry up and out. That's it. So carefully bring your planet forward. In fact, I'm going to need 2 hands. This planet, I want to say, is about 70 pounds or 60 pounds, something ridiculous. Alright, now we just have our ring gear and bearing and the low reverse support housing and piston to remove. So I'm going to reposition the camera. We're going to check this planet real quick. We'll look at the center support 2/6 clutch, and then we'll pull the low reverse section out after we pull out the, or before we pull out the rear ring gear and output shaft assembly. Okay. So here is mechanical diode rotation. Free wheels counterclockwise, locks clockwise. Okay, these are pretty hardy planets. You don't often see them bad. Given that this transmission appears not to have suffered the kind of catastrophic meltdown I thought we would be in for, most of the hard parts are in good shape. The one wild card is that 3.5R drum. So you got 2 sets of planet. This is a Ravino style carrier. There's one of these in the back of every GM and Ford 6-speed, and they can achieve multiple gear ratios using this Ravino style stacked gear set configuration. So it's a very handy design and allows you to keep the transmission case, you know, small enough to fit into a vehicle while still adding additional gears. If you had like Samson style planetaries or Simpson, it's either Simpson or Samson, one of the two I'll annotate, but if you were relying solely upon, I think it's Samson, but you know, it could be 50-50 Simpson or Samson. If you were solely relying on that style of planetary carrier design, I mean, this thing would be even bigger. So check captured bearing. Check all your planetary pinion gears. Make sure that nothing is awry with them. Okay, they should spin nice and free. All right, as far as cleaning these, yeah, you can do, I guess, a few different things. You can just simply wipe them down. Okay, I would not use any kind of solvent of any sort. Alternatively, if you wanted to, you can hose them down, pressure wash them, but whatever you do, do not put shop air to them. Because if you do that, you're going to run the risk of destroying the little needle bearings in each one of these pinion shafts between the shaft and the inner diameter of each gear. So what you then do is take the whole thing and dunk it in a big bucket of Mercon LV fluid and let it sit there until you're ready to install it back into the case. Alright, this planet appears to be fine. Alright, now we're going to go ahead and grab up on everything else in the case, and then we'll look at the 2.6 clutch. I know I keep going back and forth on this, but I just want to get the case empty. Alright, so here's our low reverse clutch pack. I want to cover the order of components. So, this is your cushion plate. It is on the back side of the backing plate. So cushion plate goes in first once you have the low reverse housing and output shaft and ring gear assembly installed. Now your backing plate. Okay, appears to be in good shape. Low reverse frictions and steels. So we got, looks like 5 and 5 or 5 and 4. Yep. So the underside of your mechanical diode serves as a clutch bearing surface. So this is really a pressure plate or an apply plate. This surface underneath here, I know you can only see part of the planet, but I'll turn it around because we want to check it. This surface is the backing plate for all intents and purposes for the low reverse clutch. All right, now we're going to pull out the output shaft. So I just took a finger, went up in here with it, and maneuvered it a little bit part way until I can get hands on. So you have your rear case to output shaft thrust bearing. So this is going to go into the case like this. You can see the 2 slots for its 2 ears, and then this portion faces the back of the flange on the ring gear. Then you have another bearing here. Check it. It's like I'm making a mess. I'm making a mess all over the floor. Alright, now your low reverse support will just come out of the case. Alright, with the case itself, there's 2 needle bearing assemblies way back here. So you're going to want to check those. There's a special driver tool that you can use to remove and reinstall these if they're bad. These should be brand new, and I'm just looking at them through the windows in the belly of the case and I don't see anything awry. One of my 6R140 teardown videos, there was one unit that came in and was missing one of the needles. I think it was on the inboard assembly. There was missing a needle there. Alright, now, there's one more thing that we got to remove, and for me to do that, this case has to be turned around, and that is the parking pole pin fastener and the pin itself, so we can pull the pole out. There's an O-ring seal on the inboard side of that plug, or pin retainer. I'll do that, and then we'll look at the 2.6 clutch. That's one of these 2 sockets. Hell with it. 10 millimeter. And there's the O-ring, a new one will come in the kit. So, over there. And grab your pole. And here's your pin. Alright. And then you have your little seal back here. It went in just like that. All right, let me get this case stood up on its bell housing. See if I can get you a view of these needle bearings. Now, let's finally get to the 2/6 clutch. What you've all been waiting for, right? So you got a cushion plate. And then your bottom steel, friction, steel, friction. These look in perfect shape, basically new. So it's a board Warner module. You know, factory, that's what they use. These are good frictions. You could run the Rabestis GPZ friction module in these transmissions. If you're going to run their friction module, you absolutely have to run their steel module. The GPZ frictions are all high energy, or some sort of proprietary material, actually, I think. And they add an additional friction and steel to the clutches, but the trade-off is that the steels are thinner. So they use thinner steels to get more of clutches and steels in there. So I'll ask the customer if that's what he wants to do here. They're not cheap. I mean, it's like I want to say a $600 or $700 upgrade, if I'm not mistaken. My last 6R140, we used them. I just can't remember offhand exactly what they cost. So you have clamshell retainers here, and then your Belleville style return plate, and of course your applied piston. I'm not going to bother taking this out right now, I'll do it later. And then you just want to check over the support. Notice your alignment dowels, you don't want to lose track of them. So they're usually stuck in here. Sometimes they'll come out for you just by hand, but most of the time you got to get a little screwdriver or something to pry them free. And I do that because I do not want these things coming out when this thing's going through the hot tank. So we'll put them over there. All right, let me go ahead and pull you back so you can see the entire bench, and then we'll summarize. All right, all in all, largely uneventful teardown. Had a little bit of trouble getting that stupid output shaft nut off. I mean, that's par for the course. I'm not gonna lie. Unless you are a full service shop and you have the vehicle and the transmission bolted to the engine, it's going to be difficult to get that stupid ass nut loose using anything but an impact. I mean, I tried to show some other methods. Occasionally they'll work, but most of the time they don't. Most of the time you just got to impact that sucker right off of there. And yeah, you're going to be replacing the pins on your spanner sockets. It is what it is. So I have a few different sockets and a small little container of extra pins. So I got to replace the pins on that one silver colored wrench. Anyway, 3.5R. That seems to be where the problem is sourced. Somewhere in the 3.5R ply circuit, there was a massive, massive leak that really hasn't made itself obvious. So I'm going to go through the valve body. I'm going to see if there's any problems there. Like I said, I have to clean it off and then vacuum test it. I don't know, maybe Ford installed just a out of spec valve body in this particular unit, and that caused the the clutch to burn. Every other clutch pack in this transmission is in like new condition. No damage to any hard parts that I could see. Everything looks good, at least at first glance. So, it's not certain as to what may have happened. I mean, if we had a line pressure control issue in here, maybe line pressure solenoid is bad, and it was not allowing for sufficient line rise relative to throttle position or load, then I would think we'd see burnt frictions and steels everywhere. And that's kind of what I was expecting, although not for that reason, for the reason the customer had stated, which is a restriction in the system that led to massive overheating. So clearly everything got hot in here, but this looks like every other 6R140 I've ever seen that comes in with 1 or 2 applied elements absolutely smoked. It's usually the 3.5R and the 4.56. In this case, it was just the 3.5R. Sometimes the 1.234 as well. So, I don't know. A bad drum maybe. You know, jury's very much still out on this case. I got to check clearances on that pump, but I think if we had a pump issue, it would have shown up in all clutch packs, especially the 4.56. But you know, we don't see that. So that clutch looks brand new, just like all the other ones in here, other than the 3.5R. So anyway, if I can find a definitive cause, smoking gun, so to speak, I will either annotate the video when this thing goes into, you know, production, or if I just can't find it or I find it later, then I will pin a note in the comments section so that folks have some sort of closure and know exactly what caused this failure. Because I really don't like situations where I can't tie a given failure of something in a unit to a direct cause. The secondary or contributory causes and root cause is not as important from a tactical perspective, because you as the builder need to address the direct cause, and then you can start thinking about what led to this and then what led to that, and start asking why until you get to root cause, but that comes later. So anyway, I'm going to try to film the whole rebuild here, get a series on the channel. And this is a good example too, because like I said before, it has everything. It's got PTO, it's got the PTO pump. The only difference between PTO and non-PTO pump is the PTO gear. I mean, that's it. So PTO, sealing rings, you'll get to see those and expanded and sized. And like I said, if you don't want to spend $10,000 on all the tooling you need, just outsource that particular task to a transmission shop for you, and you can put the rest of the case together. All right, guys, thank you so much for watching. Greatly appreciate it. If you have any questions, comments, guys, leave them below. If there's any tips and tricks that you think that folks would benefit, including me, from knowing, those of you that do these all the time, please share them. Want to continue to build a community of knowledge transfer and sharing for the 6R140 transmissions, just like all my transmissions that I work on. So, all right, take care. Look forward to seeing you soon. Thanks again.